Hi, Prof. Zhang. Yeah, I would like to clarify some questions. I'm doing this because I'm too lazy to email you in this form, so I've decided that probably a video might be a bit easier for me. So the main doubts I want to clarify is actually with regards to the four 111 planes. So as you can see here, we created the silicon wafer model. So there's this 1, 2, 3, 4 outside, and then the fifth one here. So this can actually be a 100 plane here itself, and then there are the four silicon atoms that are inside here, which this one here and this one here represents the translated 1 over 4 1 over 4 1 over 4 silicon atom. Yep, so after which drew the plane. So this is like one of the 111 planes, and behind this is another 111 plane, and here's a 111 plane, and here's a 111 plane. So currently there are 4 plane faces of a tetrahedron, but after which you can rotate this face by 90 degrees, and you can get another tetrahedron. So it looks something like this. So it looks like a very complicated star shape, and I think it's easier if we take a look from the top and we assume that this plane at the top here is the 100 plane. Yeah, so now looking from the top, this is the 100 plane. It looks as though as there are like 8 faces, but I'm going to assume here that this yellow color part here, because they are of the same geometrical alignment, this is actually considered as one plane, and then this will be the second plane, which is the green color one, and then there's obviously the third plane, and then the fourth plane. So this will constitute, if we look from the top view, this top plane here, if we assume this is 100, then these would be the 4 planes that we will be able to see from the etching. But another thing that we noted is the once you take this and you rotate it up, so if you rotate it up like that, yeah, noting that this little part here corresponds to here, and then this part here corresponds to here, that means you take this point, you tilt it up, you actually see that below here there's another plane face. This plane face is actually parallel to this plane face, but the argument that I think is correct is that this plane face here and this plane face here is actually the same plane, although not in space per se, but they are actually the same plane orientation, so they are actually considered as the same plane. Yeah, so this is a clearer representation of what I mean is that this plane here that's represented by this blue triangle is actually linked to this yellow plane here. The way that we can look at it that way is if you were to take this entire unit cube, which is the monomer of the entire crystal, and you shift it by half a unit. So you got this entire one monomer, and then you take this entire thing, you copy and you shift it. Yeah, so this would mean that the yellow color portion that is previously below the purple and green here is actually now overlapping with this yellow portion here. So actually the bottom portion of this cube is actually belongs to this particular cube, and then the bottom part of this will belong to the next mer over it. So as you can see, there are going to be many of these lines here, so it correlates back to the infinite many number of 111 crossings in our silicon chip. So I guess the main thing I want to ask is that the concept of the 4 111 planes, as I have described in this video, I hope they are academically sound, and if there are any mistakes, you could let me know in our next lecture. Thank you.